But lipids are amphipathic. What was amphipathic? Polar and nonpolar, all right? Polar and nonpolar. So alpha helices can also be polar and nonpolar, okay? Amphipathic helices. One side of the helix is going to face the outside surface of the protein. One side is going to face the hydrophobic interior. There are about 3.6 residues per turn of the helix. So if you were to plot your residues 100 degrees apart, okay? You took a full, you're doing a spiral, you're doing a circle that's 360 degrees, and every 3.6 residues is one full turn of your helix. So if you go every 100 degrees apart, you could predict the location of the helix within a protein. You could predict whether your helix looked totally hydrophobic, totally hydrophilic, or some sort of half and half. And to be half and half, this amphipathic molecule, all of the nonpolar stuff has to be on one side. And all of the polar or charged stuff has to be on the other side, okay? Such that you can draw a straight line through it. So if you have a mix where it's like polar, it's half and half, but they're like spread all around everywhere, that's not what we're talking about. I don't know if that would ever happen. We can think about how that would happen. Really important thing I want to describe, because I think this got lost on people in last year's course. This helix goes into or out of the board. A helix is winding up like this. These 1, 2, 3, 4 are not buried inside of 9, 10. Those aren't on the inside. It's a 2D representation of a 3D structure. So really, the helix is, this way, and one side of it is all hydrophilic, and one side of it hydrophobic, one side of it is all hydrophobic. I think some people are like, oh, they're buried on the inside, so they're the hydrophobic ones. I'm like, no, this is not the inside of a helix, okay? So, just in case there was some confusion with that. Okay, and so within a protein, this would be located somewhere like this, right at the surface, such that the side that's hydrophilic can face the outside and the side that's hydrophobic can face the inside. Okay. And you can also kind of just look maybe a little bit at the color coding. Every 3.6 to 4-ish residues is where you see the polar kind of come back in, more or less. Most alpha helices are amphipathic in proteins. But not all of them. Okay. Some other possible locations. All right, so this one on the right, where do we think this would be located? Totally exposed. Everything's pretty much got a charge or a polar group. There's a couple non-polar, random pieces in the chain. So this might look something like this. It might be like a kind of a connecting alpha helix where both sides could be exposed to water as a possibility. Fully exposed to the exterior. How about this one? Totally buried inside. Okay. Pretty much everybody's mostly nonpolar, so this needs to be completely contained within the hydrophobic.